In an upcoming video, I'm going to be using some retroreflective tape, and I thought it'd be good to a good topic to talk about because it's pretty interesting to me anyway. If you like shiny, flashy things like I do, you know, LEDs and whatnot, you know, eye-catching things, then retroreflective tape is right at that category. This is the kind of stuff you often see on, well, there's many different uses, but on road signs, for example. I've got some samples here. I can get more than this actually, but we'll hold off on that for a minute. So let's first talk about what it is. So this stuff is often incorrectly referred to as reflective tape, but if you wanted reflective tape, that would be like this. This is actually aluminum tape for like heating and air conditioning ducts. This is what you're supposed to use instead of duct tape, which is not. It turns out duct tape is like the worst thing you can use for ducts. But anyway, so this is just like a thick aluminum foil with adhesive on the back and this peel-off backing. And it's not intended for its visual properties, but it just happens to be very shiny and mirror-like, which makes it reflective tape. So what's retroreflection as opposed to reflection? Well, reflection, here's your surface, your mirrored surface or whatever. Reflection means that the angle something comes in at is equal to the angle that it goes back out at. So these two angles would be the same. So if the light comes in this way, it bounces off that way. If it comes in at a steeper angle, it goes back out steep. If it comes in shallow, it goes out shallow. If it comes in straight, it goes back straight. Angle of incidence is equal to the angle of reflection. So that's reflection. Retroreflection is a peculiar thing where whatever angle the light comes in at, it goes back out the same way. It comes in here, it goes back there, and now, or in a relatively narrow area. It's reflected in a narrow area, not perhaps exactly, but you know, a very fairly tight beam, and that's what gives this stuff its amazing properties. Now, I've seen people be confused about this. Like on Amazon reviews for reflective tape or retroreflective tape, when I was looking for some of it, somebody complained that, well, the light it's only bright in the direction that the light came from, but that's why it works, right? It's if it didn't do that, there would be two possibilities. One is the light is reflected, it comes in, it goes out at the, you know, the opposite angle of where it came in, which would be this, or it's just dispersed generally. It goes back in every direction, which would be like masking tape, you know, something that's just not kind of, you know, very diffuse light, kind of sends light back everywhere, every which way. So the point of retroreflection, the reason it works out, is that when you're coming up on a, let's say this is your car, and get your headlights, and then get your eyes here. So what happens is if you have like a I don't know, a tree or something, excuse my extremely crude drawing, the light from your headlights is going back just everywhere, right? It's just kind of bouncing off generally. So only a small fraction of this light is making it back to your eyes. Just a little bit of it happens to be coming back here, and then that allows you to see it, right? But it just, everything has roughly the same properties. You know, everything in your field of view is going to be, you know, more or less reflective a little bit or whatever, but it's not, it's all kind of going to be roughly uniformly bright. What retroreflection does is it takes, let's say we have this road sign here, and another crudely drawn car, and here's your eyes, here's the headlights, and the headlights are shining like that. And all this light, and this is a much further distance, so I should have drawn this like way over here, but all this light is coming back in a relatively narrow beam. Well, I should redraw this again. Not terribly clear. Let me make it much smaller here. Here's your car, the headlights. Way over here is the sign. So your headlights are shining and hitting the sign, and of course hitting all sorts of other things. But all of that light that's hitting that sign is coming back in a very narrow beam. So it you know, a much higher percentage of the light, like very little of this light is coming back to you, but all the light that's hitting this or hitting this tree is coming, or bush or whatever, is coming back to you. But like almost all of this is, or a large percentage of it. So it seems like very, very bright. It really pops out from the background. It almost seems like it's a light itself. Now, if you just had a reflective surface, then the thing is, if this sign was, tilted a little bit, it'd have to be exactly the right angle between the lights and your eyes. Basically, you'd have to be seeing it exactly flat or almost exactly flat. Otherwise, the light is just going, if the light happens to be turned a little bit, it's just going to go all back here, and you're not going to see it at all. All you're actually going to be seeing, let's say that the light is or the sign is tilted up and it's reflective, you'd actually be seeing the sky, the dark sky or whatever. So that's why retroreflection works. Retro means the light comes back exactly the same way it came in, and since all that light that's hitting the object is coming back to the source of the light, it seems really, really bright to you, stands out from the background, catches your attention, and serves its safety purpose. Okay, so retroreflective tape comes in a bunch of different grades. Well, there's all kinds of different degrees of how effective they are at returning the light to you, how wide that beam is, how efficient they are, and then all sorts of other properties, physical properties as far as being weather resistant and how long they hold up outdoors and all this kind of stuff. But in terms of common use, there are sort of 3 different grades that you might see referenced. There's engineer grade, high intensity, and diamond grade, and that's from the lowest to the highest brightness. There's other properties too as far as mechanical properties, but and I don't know that this conforms to any particular spec, or grade, but engineer grade often looks like this. It's a very uniform looking, just a little bit sort of sparkly, just a tiny bit, and very smooth effect to it. And that kind uses little glass beads or bubbles in it to do the work, and I'll show how that works in a minute. Another kind, the higher grades usually have some sort of pattern on them. This, I don't know if this is really high intensity or not. It seems pretty bright, but I don't know if it actually meets the spec. It claims to, because this is a conspicuity tape. It claims to meet the C2, the Department of Transportation C2 rating. Who knows if it actually does or not, but the higher grades usually have some sort of pattern in it, and they use a prismatic or kind of I'll explain that in a bit, how that works. I have seen really crappy knockoff stuff that was it wasn't even reflective as this stuff. It's just barely retroreflective. And what they did is but it's this style where it's the glass beads, and then they just printed this kind of a pattern over it to make you think it was the higher end stuff. So this is purportedly high intensity, and then this stuff here, I don't know if this is actual diamond grade. This is, but it is diamond shape, and this is genuine 3M, I believe, stuff. So this could well be real diamond grade. So this would be kind of, if these were, if you had the light shining at all these in the dark, this one would be the dimmest, then this one would be brighter, and this one would be very bright. I'm not even going to try to do that on the camera because it's so hard to give you on video a realistic impression of how bright it actually looks in real life. And the brightest one will swamp out the other ones. It just doesn't. Cameras don't work like your eyes do, so it's not ever going to be a very realistic thing to try to show you on video. Okay, so let me show a little bit about how this stuff works. So as I said, there's kind of the glass bead kind, and then there's the more advanced kinds. The glass bead kind has I see lots of little spheres of glass. The tape, and there's your backing, and then there's clear stuff, or maybe with the color. I'm not sure which layer the color is on. It could be above or below, and then you've got clear stuff up here. But anyway, embedded in the stuff is these glass spheres, and what happens is that however light, these are terrible circles, but anyway, however light comes in, it hits the center of this curve, it comes back out. If it hits out a ways, it can kind of skip around the inside and come back out, but it's not, it certainly gets more light coming back to you than just a regular flat surface, but it's not super efficient. The more advanced kinds, I'm going to do this in 2D version. But let's say, imagine you had a surface like this. So if light comes in straight, I'll do one more. If light comes in straight, it hits this. These are 90-degree angles here. It comes in, so this is a 45-degree angle it's hitting it at. So it's going to leave at a 45-degree angle. It's going to hit this at a 45-degree angle and come back out. So it's going to come straight and back out like that. If it comes in at a wider angle, it's going to leave, or kind of a shallower angle to this. It's going to come in at a exit at a shallower angle, but then it's going to hit this at a the wider this angle gets, the narrower this angle gets, and it compensates. So it kind of comes in this way and goes out that way, or it can come in here, go back out like that. So this kind is much more efficient because kind of wherever you hit it, it works. And basically, the tape is a 3D version of this. There can be like well, sometimes they're like tetrahedrons, kind of like raised tetrahedrons in a pattern. Oh, I did that wrong. But anyway, raised tetrahedrons, or they can be different variants of this. There's also a kind called a style of retroreflector called a corner reflector, which is basically the 3D version of this. So it's, instead of like this where it's hitting, bouncing and coming back out, it's this in 3D, and like this, and wherever it comes in, it does the 3D version of that. And those have some other interesting uses, the corner reflectors.